Hello, everyone. Welcome to section 5.2, where we will look at moles and mass. These are the learning objectives for section 5.2. Be able to find the molar mass of an element or calculate the molar mass of a compound. Use the mole concept to convert between atoms, moles, and grams for elements and compounds. Okay, so let's talk about the atomic mass and the molar mass. The atomic mass is the mass of an average atom of that element, and the units for that are the atomic mass unit, or AMU. This number is found on the periodic table. It is the number below the symbol of the element. It is not a whole number, so we're not showing it, but the number above the symbol of the element is a whole number. For magnesium, that would be a 12. And the number below that is not a whole number is the atomic mass. So that is the average for any given element. For our case, we are more interested in large amounts of elements. So we can refer to this same number as the molar mass. This is the mass of 1 mole of that element and units of grams. Okay, so what we're doing is we're defining this in terms of units we're familiar with and comfortable with, units of grams. So we've already been measuring grams in the lab quite a bit. And we can look at the periodic table and we can look at that number and we can get a sense for how many moles we have of a given element. When we do this, we are using a number from the periodic table. So as we go through this section, you probably want to have a periodic table in front of you so you can look at how to solve these problems. Speaking of which, let's go ahead and look at our first example. Again, you probably probably want to go ahead and pause your recording, try to solve this, and then come back and watch the solution. Okay, our question: how many atoms are there in 3.65 grams of sulfur? That is the question. There is one number in the question. So let's go ahead and write that down. We have 3.65 grams of sulfur. And I'm going to write question mark atoms of sulfur is what we are looking for. But again, we're given just one number. I'm sorry, let me go ahead and move this over so you can see it. We are given just that one number. There is a little bit of a hint up here to help figure out the process. You will not always be given this kind of a hint in questions. So the idea is you want to be able to come up with the process we're showing here. And if it's helpful to look at that as we do this first example, feel free to do so. But remember, you're not always given that information. And the information given in this particular problem will not apply to every single problem. So how we want to think about this is we want to think about what information do we know that is not written down that would apply to this problem. And so one piece of information is we see the word atoms. When we see the word atoms, we should always think of Avogadro's number. So let's go ahead and write that down. So 1 mole of sulfur is equal to 6.02 times 10 to the 23rd sulfur atoms. Okay. And then the other piece of information that will be useful is knowing that we are talking about sulfur, specifically sulfur. So what we do there is we look at a periodic table. So we see 1 mole of sulfur is equal to 32.06 grams. So go ahead and make sure you can find this number on the periodic table. And then let's see if that's enough information to solve the question. And remember here, so part of this is figuring out how to write these equalities. So which equalities do matter for this question, and then writing them out, and then hopefully that's enough information. So if you're stuck on a problem, I would recommend starting by doing something like that. So let's start with the 3.65 grams of sulfur. And then we look for, do we have an equality with units of grams? And we see grams right here. So let's go ahead and use that. So we have 1 mole of sulfur on the top and 32.06 grams on the bottom. And then we say, okay, now we have moles. Do we have an equality with moles? And we do. And is that equality giving us what we want? We want atoms. That would help us get to atoms. So we put Avogadro's number on the top. And then we put the 1 mole of sulfur on the bottom. Okay, so we've set up our problem. Let's see if the units cancel. So we have grams of sulfur cancel, moles of sulfur cancel, and we're left with units of atoms. Those are the units we want. So then on our calculator, we multiply across the top. So 3.65 times Avogadro's number, and then divide by 32.06. And when we do that, you should get 6.85 times 10 to the 22nd sulfur atoms. Does this number make sense? We have a mass that we could weigh on a balance in the lab, and we have a number close to Avogadro's number. That seems about right. It's a bit less than Avogadro's number. We have less than a mole. So we're probably in the right ballpark here. So we can be comfortable with that being the correct answer. One other thing I want to just mention about this question, as you're doing this, remember, you have to decide which things are important. Right now, we've only got a few things to consider. As we keep adding to this, we'll get more and more things that could matter, and the mole is often going to be in the center of everything we do. Okay, so if you are trying to set up a problem and you're not sure what to do, it is often correct to figure out, how do I convert to moles from what I have, and then maybe reevaluate at that point to figure out how to get to whatever you need to do next. Okay, so we went through that. Again, feel free to watch that as many times as necessary to, if that's helpful in understanding it. Even come back after you've done some sample problems if you feel like you're getting stuck, and continue to watch that if you find that helpful. Okay, I want to move ahead a little bit and talk about compounds. So we've looked at some elements. We can apply the same idea to compounds as well. If you have a compound, you can find the molar mass of the compound by adding together the molar masses of the elements in the formula for that compound. So I'm showing one example here, and you will get some chance to practice on some additional examples on your worksheet here in a minute. So we look up, let's say we're looking for calcium CaCl2. We'll talk about how to name this. I guess we've already talked about how to name this. So calcium chloride. So in the formula, you have 1 calcium. We look up calcium, we get 40.08 grams per mole. So that's the molar mass. We look up the chloride, we get 35.45 grams per mole. In the formula for this, we have 2 chlorides. Okay, so we have 2 moles of that. So we multiply that by 2, and then we add all of these together. So we have the calcium, we have the chloride, we add those together to get the 110.98 we're showing here. One quick note here on significant figures. When you are looking these up on the periodic table, if you have 2 decimal places, that should be sufficient for anything you will need in this course. So we're going to 0.08 here and 0.45 in this case. So just an example, you'll get more practice on some of these here shortly. Okay, the last thing I wanted to talk about in this section is looking for conversion factors from chemical formulas. When we look at a chemical formula, that chemical formula is itself a ratio, and it's something we could use as a conversion factor. So here we're looking at carbon tetrachloride, and every time you have a carbon tetrachloride, you have four chlorines. So we could write this as an equality. So we have 1 mole of CCl4 is equal to 4 moles of Cl. So if you had a question where you maybe are given some amount of, maybe you're given the mass of CCl4 and you want to know how many chlorine atoms are present, this would be one of your conversion factors. Now, the thing you'll notice in this conversion factor is that you have moles and you have moles. You're comparing moles of one thing to moles of another thing. So when you do this, it's important to show, not just the word mole, but mole CCl4 and moles of Cl. This is also illustrating the idea that the mole is a central concept. So we can have conversion factors for moles over here for CCl4. We can have conversion factors for moles of Cl over here, and then we're relating the two by this particular equality. I'm not going to go through a specific example of using this, but you will see some on your worksheet. Feel free to ask questions about that on the discussion board if you're not sure how to do it. Okay, so that's the end of this section. So go ahead and complete worksheet 5.2. If you have any questions, ask them on the discussion board, and then proceed to 5.3 when you are ready. One thing I would like to say at this point, I would highly encourage you to complete that worksheet before moving on. And in fact, I would even encourage you to do some of the homework questions related to these concepts before going on to section 5.3. Section 5.1 and 5.2 are looking at moles in one way, and we'll be looking at them in a little bit different way in section 5.3. So I would like you to master these initial concepts before moving on to the others to avoid some confusion.